Hello, welcome to today's webinar, Core's Integrated Toolbox, Delivering SysML with Integrity and Efficiency. My name is Eva Dace and I'm a member of the Marketing Department here at Vitech. I'll be your host during today's webinar, which is being presented by Ron Kratzky. Ron holds the position of Principal Systems Engineer with Vitech's Professional Services. He's a retired U.S. Navy officer with over 20 years of engineering experience, managing nuclear engineering and combat systems on surface ships. He was introduced to the systems engineering practice near the end of his naval career while conducting mission and capability analysis for the Navy staff. For the last 12 years, Ron has worked as a systems engineer, supporting advanced systems development for a number of federal government agencies. Ron was introduced to Core in 2007 and used Core to manage system development tasks on 3 different projects over the last 5 years. Now, before we get started, I would like to review a few housekeeping matters. Please take a few moments to get comfortable with your webinar control panel, as this is how you will be able to submit your questions throughout the presentation. We will address questions at the end of each section and also at the end of the webinar, so send me your questions early and often. Next, I'd like to answer our most asked question. The webinar is being recorded today. You'll be able to find a recording in the webinar archive in the resources section of our website. And I will be sending out the link to you now. So now, without further ado, let me hand it over to our presenter. Welcome, Ron. It's great to have you with us.
Thank you, Eva. It's great to be here. So today, we're going to talk about delivering SysML with integrity and efficiency. And this is really a follow-up, if you will, or the second chapter in a presentation that was started by Warren Smith. I guess it was 2 weeks ago now. And Warren's webinar is available on the same webinar link that Eva is chatting out right now. So if you want to go back and look at Warren's webinar after this, please feel free to do so. In Warren's webinar, he really talked at length about how to develop SysML views in Core. So I'm really taking this presentation from that point and asking the question, is SysML enough? Is SysML the only thing that a system engineer needs to do to meet his obligation? If you look at SysML, there's a number of different drawings, and Warren went through a bunch of them. And he developed a sequence diagram, he developed an activity diagram, he developed some block diagrams, he developed a requirement diagram, and he did that based on some initial requirements that he was given by the customer and some initial set of operating guidelines, I guess you'd say, as to what needed to be done. But the question is, if you've done that, you feel pretty good about your system. Is that all you really need to do? Maybe further those models, continue the development. But I think there's other things you need to do, and if you're going to be using a model-based systems engineering tool, that tool needs to support more than just those SysML views. It needs to support other things that you do as a systems engineer. And so Warren talked a little bit about SysML, or he talked a lot about SysML, but I just wanted to review what SysML is. And SysML, if you go back and look at the requirements or the initial guidelines of what SysML is, it's really a modeling language. It's designed to provide a set of rules, if you will, on how different diagrams should be made. And those rules and those diagrams are based on a set of information that allows a systems engineer and other engineering disciplines to design a system. And I emphasize the fact that it's for systems engineers and other engineering disciplines because it is a precise and unique set of language. But it's not enough to communicate in SysML language to everybody that's involved in a project, and I'll get back to that in a moment. If you will, one of the analogies I like to make about SysML is much like the DODAF architecture framework. The DODAF architecture framework provides a set of rules and guidelines for producing architecture views for DoD. It is not the only way to produce architecture views, and it's not the only way to produce operational architectures, but it is the way DoD does it. If you're familiar with the architecture community, there are other ways to do architecture. There's a federal enterprise architecture framework, and there's other architecture frameworks that have been developed by other countries for their defense systems. And there's also the great granddaddy of all architecture frameworks, which is a framework that Zachman has put together called the Zachman framework. If you're familiar with that, it's a totally different, in many respects, type of framework, but it's a very open framework and allows you to do things in many different ways. So SysML is really a visual modeling language, and it's not a methodology, and it's not a complete tool set. In the SysML webinar, we completed several SysML views based upon those customer documents and those use cases. This is the webinar that Warren did 2 weeks ago. And he developed a use case, which you can see up here, and he developed this a set of requirements for the ventilation system that he was working on, and he developed a sequence diagram and an activity diagram, and he had that activity diagram. He had two of them, one to set up the patient, and he had another one that showed the different activity diagram blocks. But if we look beyond those SysML diagrams and talk about what is a model-based systems engineering tool, you got to talk about the model. And the model is an abstract representation of an entity. It's a very basic name for it. And COSI defines MBSE, as it's stated right there, and it's the formal application of modeling to support systems engineering requirement design, analysis, verification, validation in the beginning of conceptual design phase and throughout the development and later life cycle phases. So that definition to me has a huge connotation and a huge set of things that need to be done through whatever this tool set is. And so to me, we have a system modeling language that provides us a set of constructs in views, but there's much more to an MBSE approach than just those SysML views. So what do you have to do as a systems engineer? What do you end up doing? Is creating those SysML views enough? Is that what you need to do? Is that your primary role? Well, I look at it a little bit differently based upon my experience, both as a systems engineer and a project manager for the last 12 years, not in DoD, but as a commercial guy, either working for a federal government agency or on a commercial project. And really, to me, I only exist as a systems engineer inside of a project. The project is to develop something, and there's more to that project than just this technical engineering design. There is the whole project planning and control aspect of it, and there is the whole systems engineering aspect of it. So I'm a systems engineer. I don't so much worry about the project and planning and control, but I have to interface with that side of the project. We have project planning, resource allocation, and financial management. That's what a lot of the project planning and control is worried about. As a systems engineer, I need to do the systems architecture. I have to do technical coordination. I have to do all the systems integration stuff. But there's a lot of things in the middle there, defining the tasks that I need to do, looking at risk management, and how do I interface with the customer. Customer interaction and customer interface is much different than interfacing with the engineers on my team and the engineers on the stakeholder or the government's team. So if I'm going to do all that, and I'm going to support all that in some way, shape, or form, I need to be able to do more than just the SysML language. Now, Warren talked a lot about this, about what should be in an MBSE, what should be in a model-based systems engineering process or paradigm. And we talked mostly about what's the underlying model, providing an underlying model of the system, the design repository, one design repository, sharing information with other team members. We talked about the unambiguous notation, the clear structured language and defining design. And we talked about, generating the views from the model, and he showed us how we did those SysML views and how they came out of the model. And then we talked about a complete queryable virtual system prototype. And I'm really going to focus on probably the last two bullets and talk about how we have views in a model-based systems engineering tool that's tailorable to the audience, that we can maintain consistency as changes occur in the model, that we handle all aspects of systems engineering, not just getting some of the technical engineering down and be able to produce the SysML views, and how we can do prototyping of the system within the model. So if you're going to have an MBSA tool set, it's got to support all of these items, as well as whatever engineering syntax your process requires, whether it's SysML or some other engineering syntax. So here's the way as I sat down and thought about this presentation. It's not just doing the SysML views, but it's all the other things I get asked as a chief systems engineer, chief system architect, or the project manager. Those are the things that I end up spending a lot of time on. Things like the customer wants to review the system breakdown structure so they can better understand what the system is you're designing. Or how about the customer's program manager, who's not an engineer, needs to communicate the system's interfaces to a stakeholder group. Can you provide a solution at the meeting this afternoon? Typical day, typical Monday morning in the office. And then they want to know what concerns I have on the system design and what risks am I monitoring on the system design. Oh, tomorrow there's a meeting of the T&E guys, and they want to see the verification cross-reference matrix at tomorrow's meeting and understand where I am with verification and test planning on my system. And the customer's chief engineer wants to see the latest design description document, and he wants to see that version by tomorrow morning. So there's my work plate for a Monday morning. How am I going to answer all those? Well, we're going to start at the top and work our way down through all of these questions to see how our model-based system engineering tool set will answer all these questions. So we have a concept in core. We use hierarchy diagrams to a great extent. The system breakdown structure is a very simple way to show the system layout, and it can be shown in a hierarchy diagram. Warren showed it in a block definition diagram and I think a classification diagram, I can't remember. But sometimes those diagrams, and you can see the block definition diagram in the background over here, those diagrams get a little clunky for the non-engineer program manager who wants to show the system that he's having our engineering firm build, and he's going to show that to the board of directors at a dinner meeting on Thursday night. They don't want to see the block definition diagram. They want it in nice, easy chunks to understand. And there's different types of hierarchy diagrams. If I was to show the customer a hierarchy diagram in the system context like this and show him that this is the system of interest that I want to look at, that would be much more understandable and easy to grasp for a wider audience that was not necessarily systems engineers. And they may want to know exactly how these systems fit together instead of just being general components. How does the system, subsystem, and segments go together? So these hierarchy diagrams provide an essential way to show system design information in a view that stakeholders can easily understand them. There's other ways to simplify those SysML views. We have the activity diagram and a sequence diagram. They came directly from SysML and UML practices, which in turn came from the software development world. But there's other diagrams that directly relate to those activity and sequence diagrams that are easier for people to read and sometimes more intuitive for specialty engineers like interface engineers. And so I've given a little chart down here to show, the SysML UML convention of activity and sequence diagram. This can also be shown in an FFBD or EFFBD diagram. This is a functional flow block diagram or an enhanced functional flow block diagram, and I'll show you what those are in a moment. And these interface block and IBD diagrams can be shown easier in an interface N2, and the flow interface block diagram and the physical block diagram are shown more easily in the physical N2 diagram. So let's go to core for a moment and look at some of these hierarchical views and how we get those and how easily it is to draw some of those. So if you will here, I'm going to escape out of this and I'm going to go to the core model here. I'll just give it a moment for the view to refresh. So we were in this model last time, and Warren showed and developed this use case, and you'll recognize this use case if you were in the prior meeting. And he developed this use case, and he developed another use case here, and he also developed a set of, from that use case, he went in and he developed an activity diagram, which, let me go to this one here, this activity diagram, and he developed a sequence diagram that went along with that activity diagram. Now, that activity diagram or this sequence diagram has a lot of information on it, and it's hard for some people to read that diagram. Either of these two diagrams, when we develop those as activity or sequence diagrams, they also become EFFBDs and FBDs. So this shows the functional flow in a very easy manner for people to understand. And the enhanced functional flow block diagram shows all those triggers and inputs and outputs that we had on the activity diagram through these green bubbles and these double-headed arrows, which many people understand more intuitively, if you will, than they do this activity diagram, which provides a lot of information in there, or the sequence diagram. Now, let's go back to the component side here for a moment. And when Warren put this together, he had a lot of different components in here. I cleaned it up a little bit prior to starting this presentation, and I wanted to show you the hierarchy diagram and how I got there. So in the hierarchy diagram, all I did was slide this over a little bit so we can all see it. What I did was I made some relationships here to show that the context of the system is built from really a patient, a maintainer, and a nurse. And if you go back to the use case we had earlier, in the use case that we had established here, we had a nurse, a patient, and a maintainer providing some functions in there. So I put this together in the system context. And I have my system here, which is the ventilator, and I'm looking at the child respiration unit in this case. And all I did here was I added a shape onto here to highlight the system of interest. You can do that by just pulling a new shape onto your diagram and changing this. I can change this to show that this is the external components here. and I can change that, manipulate that, change the fill color to provide a different color. And now I can see the difference here, and I'll actually move this. I'll move this to the left. So now I have a different, these are my external components, and this is my system of interest. Now I need to, the question was, I want to give this to the customer, so how do I get this out of my tool? There's several ways to export this, but I'm just going to say diagram save as. I'll save it as a system context diagram. It uses the name that was at the top. I'll save that as a JPEG, and I will simply start building a presentation for the customer, because he needs to, I need to give all this information to him at the end of the day. So I'll go into my, I can take this, I'll copy it and drop it into my day in the life of the SE here. So I'm on this slide, and I'll just drop that into onto my slide if that's what we want to talk about at the meeting later on today. So I haven't used a SysML diagram here, but it provides a representation that the customer, I think, will understand. I can look at I can then look at the respirator, which is the key item that he's worried about, or is the respiration unit as a child here. I'm now in this. I'm now showing a breakdown of the child's respirator, but what I want to do here is I want to change this diagram around a little bit. What I'm going to do is take the frame off, because he doesn't understand, he doesn't want to see the frame. I'm going to use the local icon settings, and I'm going to do it like this, and then I'm going to change, instead of saying component now, he really wants to see the what type of components these are in my system. And now that I look at this, I see that I really haven't typed any of these systems here. So how easy would it be for me to change that? I can highlight all these, and I can set that attribute, the type attribute. I'll select type and change those to, I'll just call them system elements for the time being. Go back to my hierarchy diagram, and now I've got a diagram here that makes a little more sense for the customer. What the things he really wants to know is, how am I putting together the respirator and the components that are in there. So I'm going to highlight these elements, and I can color them, fill them in with a different color. Let's say I'm going to use blue for these, but they look the same as my background, so now I'm just going to change my background color to white. And now I'm going to save this diagram and put it into my PowerPoint slide. So again, now that I've got this in here, I can copy this, put this in the presentation I have to give to the customer. There you go. We can put notes around that, whatever we want to say as far as the system breakdown structure for the child. Now, one of the other things he wanted to know, he wanted to understand, I know from experience of talking to this customer, he also wants to understand the interfaces that occur here. So we made this diagram as the SysML diagram, but it might be easier for him to understand this diagram. So again, I can easily export this N2 diagram to my PowerPoint slide, to my PowerPoint presentation that I'm going to give to the customer, just as easily as I did the other ones. And finally, I want to make sure that he understands the context of what goes across those interfaces, so I want to look at the links that are part of this diagram. When we did it in SysML, we looked at the flow IBD. And this has a lot of data in here, certainly data that we need to understand as part of the system, but this is probably a better representation of the physical, the flow IBD and the physical N2. So what I want to do here is I'm going to change this a little bit. I'm going to take the frame off of here again, and now I'm going to change some of the icon settings here so that I can get the whole name in the picture. Now I've got the whole name of all these exterior links that are going on and the internal link that's here. And again, I can just now save that diagram and move it into my PowerPoint presentation. So now that I've gone through all of this, I think I've got pretty much the so now I think I've got a presentation to provide the customer with all of these, with all of the things he wanted to look at in the system as far as the system breakdown structure is concerned. So let me go back to the point in a second, to my presentation in a second. I provided the system breakdown structure, and I provided a way to communicate these systems interfaces to the stakeholder group. So the first two tasks are done on my task list. So does anybody have any questions on the hierarchy diagrams or how we did the interface diagrams in an easier way for the customer?
Hey, Ron, actually I do have quite a bit of questions. Let me start with the first one. It's from John. He asks, is there a publicly available standard for FFBDs and EFFBDs that describes the diagram standard symbology and terminology?
I don't know if there's a public standard. I do know that there's two books that we have used in core that relate to FFBDs and EFFBDs, and those books are Engineering Complex Systems with Models and Objects by Oliver, Kelliger, and Keegan, and the other one is The Engineering Design of Systems and Methods by Models and Methods by Dennis Beatty, who's an instructor at George Mason University or Stevens. I'm not sure which place he is, but we can. I will append those two references to the end of this slide when we post it on the webinar page. So I'll add a slide.
All right, that sounds good. I have one more from John. Actually, I have a couple more from John. His next one is, in the hierarchy diagram, can you show the level 3 elements in the column to the right of the level 2 elements?
Okay, let me go back to my well, wouldn't you know it now? Here we go. PowerPoint needed to wake up, I guess. So I think what you're asking for is, if I go back to my hierarchy diagram here, if you wanted to show these to the left, the level 3 elements to the left, you can change this to an org chart like that. You can also change this representation that it's vertical is the way we did do it. This is the the organizational chart. You can do it hanging there, so I can show those to the right, not to the left necessarily, and you can show them horizontally that way. But these are normally read left to right, not right to left. So left to right is the way we view things, or the way we think about things.
Okay. John, let us know if that answered your question. Feel free to elaborate on that a bit if not. Our next question is from Cameron. He asks, were many of these diagrams created automatically from the original context diagram?
Well, the answer is yes, and the way it's not necessarily drawn from this. This diagram, the hierarchy diagram here, is built on or uses this built from relationship to create this hierarchy diagram. Okay. If I was to go to this diagram here, we'll go back to this for a moment, and there's various hierarchy types that are available in Core that we have sort of predefined for you to show different traces, if you will, or hierarchies through the system. Now, the physical diagram, and I'll go through how that's created here, but if I look at this, and this traceability was physical, and physical uses the built from relationship and creates this hierarchy diagram. If I looked at a different diagram, this is traceability, and this traceability will show me where that component, what it's out, what functions and what concerns may be generated and how it's refined. Traceability is generally used with requirements, and let's go to requirements here, and I'm going to jump ahead here, but I'll look at R138. We'll look at the system requirements here. Instead of this requirements diagram like this, we can look at it in a hierarchy diagram, and you can see that this requirements diagram uses this traceability, and we talked about the traceability here being defined a particular way, and you see it has this generates, and actually I'm going to get into this next about concerns. You can see that generates is here. Next I'll get into concerns, and you'll see that this requirement generated a concern, and that concern is colored in this tan color, which is a preset color for concerns that's part of the user-defined colors for Core. So I guess the bottom line is the hierarchy diagrams are auto-generated based upon two things: the relationships you put in the model and the hierarchy diagram type that you select, or the hierarchy diagram type that you create.
All right. Thank you, Ron. So we have a couple more questions. Now, in the interest of time, do you want me to go ahead and handle all of them now, or would you prefer if we wait till the end?
Let me go on and cover. There's a couple more areas I want to cover as far as my job here as the systems engineer, and let me cover these next couple of areas, and then we'll come back to some more questions there.
That sounds good.
But it's interesting because I really think that more than half of your time as a systems engineer is being able to draw a drawing that answers a question and provides the information in a manner in which the customer will understand it. And that's where a lot of these questions, I think, are coming from. And Core has a very robust capability to show these drawings in a number of different fashions. So it's much more than just those SysML views. So as I'm going along here, the question I got asked as soon as I as soon as my first set of questions were done was what concerns and risks do I have on the system? So I want to talk about concerns a moment. And the way we view concerns in core is that anytime you're designing the system, and generally you're starting from a set of requirements or bringing in a COTS systems into your design, you're going to have concerns as the engineer. And one of the things we really stress is being able to document those concerns, provide traceability to what caused you to have that concern, and then to provide traceability into how you resolve that concern, because you're going to make a design decision, or you're going to make a change in the system in some way, shape, or form. So commonly, these concerns come about because requirements aren't clear, they're contradictory, or they're over or under specified, or you've got some COTS element that you're required to use, but once you start looking at the design, you're not sure that the performance of that COTS requirement is going to meet the requirements of your design. And there's lots of other situations. So we have a way to capture those in core that provides clear visibility into the concern and traceability, and supports and will be provided in design documentation. So we have a concern class here, and I'm going to walk through in a moment exactly how to generate this table of concerns and how that's made. But the other part of the concerns, a lot of times you have a concern and you can't resolve it, and it becomes a risk. And so a risk could exist for many reasons, and I don't want to get into a whole discussion on risk management. We can save that for another time, but I just wanted to introduce the fact that we have risks in our model, and those risks have the same traceability and same ability to show what changes are made in the system design as a result of this risk. So we can create risk elements, and I'll walk through and show you where those risk elements are. And then finally, we can easily produce a risk report. So let me switch back now to the model, and I'll just go down to the next one. So I'm going to answer these next two questions about what concerns do I have in the system design, and what kind of risks do I have. So in the model, that, again, going back to what Warren was working on before, we have these requirements. And if you remember from before, Warren came up with these set of requirements that he wanted to put into the model. I also looked at all the requirements we got out of doors and cleaned those up a little bit to come up with these list of requirements. Now, as I'm looking at these requirements here, there's various ways to look at requirements. I just want to expose a different way to look at it, and this is the table view in core, and this provides me the number, the name, the description, the type, and the origin of the requirements. I can easily change what I see in this table view by selecting new columns and adding new things into this table view. But as I'm sitting here looking at this and trying to get to my concerns, my requirement engineer walked in and said, "Hey, what do I need to do today? After our meeting last week, I forgot what it is you wanted me to do." Well, what I wanted him to do was to handle all of the requirements that are not yet typed in my system design. So I can easily tell him, look, here are the untyped requirements in the system design. Go into the model, look at these untyped requirements, and here I lost them. Hang on. Look at all my untyped elements here. Look at all my untyped requirements. I'd like you to go through that list and get those things typed, because they don't have the typing on these things is all incomplete, and you can go through here to see all of the untyped requirements that I have. So I can give him that list and say, go off and do that. I've got to answer the concerns and risks that I need to do for the project. So if I go up to my concerns, you see that I created a list of 5 concerns earlier this morning, and they're generated by a series of requirements. If I look at concern 2 was a requirement here that had a list of functions that weren't clearly identified. So I'm going to say that I'm going to assume that these are my standard list of functions, and what I did was I went back into my requirements list and I wrote these 3 requirements up here. I want to relate those requirements to the thing that caused my concern. So I'm going to take that requirement, it's going to be refined by the 3 requirements that I added this morning. So I've added those 3 requirements as being refined by those requirements. You can see now they're refined by these requirements. I'm going to take and renumber those. They're now up here, but each of those have a type functional, and I typed them all as design decision. It was my design decision to say that those requirements meet, and I haven't put a description in here, but they meet that CO2 monitoring. And so, but my initial task was to look at all the concerns that I had. I have these concerns. What I want to do is produce those for somebody. I want to take these out of my model, so I'm going to export them to a Word document. I'll go to concerns. Next. I have some predefined ones, but I made a new table called the table of concerns, which I've typed right here, which I've created here. And this, by the way, is just an easy way to go through core and look at, grab a particular element and walk through the attributes. I'm going to get the number, I'm going to get the element name, I'm going to get the description, and I'll get the status and the importance of that concern. So now I have my list of concerns printed out. I can save that, and it's already saved actually, it just opened up in Word. So I have these list of concerns that I can take to the customer. Notice I have a critical one and I have a series of essential ones. If I was a chief engineer, we're going to a little design review meeting. I have my list of concerns now. Those things can be acted on by my team. Go out and resolve these, or work with the customer to resolve them. The next thing I wanted to look at was risks. We actually developed a series of risks in the last meeting, but I have these risks here. The different risk on system failure. There's another risk on power outage, another risk on airborne disease contamination aspirating back into the ventilator, and how do we solve those. Each of these has a consequence and likelihood on the secondary tab for each one of these. And what I want to know is, how do I get this risk register out? Well, we have a report in core that allows me to take this risk out of the system into a Word document, and I can put the risk cube table and details in, and I will get a report. Now I have a risk report. There's the risk cube showing what the individual risks are and where they're located on the cube. The risk rating and name, this table just shows me the risks, high, medium. It'll print out all the high, medium, and then the low ones, and what the name is and the likelihood and consequence. And then I get the detailed report of what I'm doing for each one of these risks. So I've now provided the system breakdown structure. I provided a set of N2 diagrams that are much simpler to view than the interface diagrams, and I've got concerns and risks. Does anybody have any question on how to get the concerns and risks done?
I do have a few questions. They're actually all from John. He asks, is each functional requirement mapped uniquely one-to-one to a performance requirement?
Well, they're supposed to be, but this model that I'm working in right now is not fully complete. So if you look right now, if you were to look at, go back to my requirements, and if I looked at my functional requirements, I have typed these requirements as functional, and if I look at them right now, you'll see that they're refined by, there's the description, they're functional. But if I wanted to change this table right now and edit my columns, and I added the basis of on here. Now I made the mistake I always do when I do these tables. I told myself I wouldn't do this today. You add that, I'm going to take off the refined by, I'm going to remove that. Say okay. See, I don't have any functions assigned to these yet. And so that would be another thing that if I was working with my team, I have all these functional requirements and I have all these functions that they've put together. I have all these functions that they put together here, but these functions aren't, based on any requirements. So we've got to pull our system design together, if you will, by making sure that these functions are assigned to requirements, and the functional requirements are assigned to functions. But right now I've done a bunch of functional analysis, but haven't tied my design together with the functional requirements. But in practice they should be, yes.
All right. Actually, that was the one question for this section. The rest he was clarifying this section, so we can continue.
Okay. So the next thing I have to do is someone has asked me about the test planning and review committee. Is my VCRM ready for tomorrow's meeting? Actually, I'm going to go to a different model here because this is a model that it was developed to show the initial development features of core. If I had done all of the initial design, then I would set up a list of verification requirements. What I'm going to do is I'm going to open a different model here, and this is a model that's built out much further. This is a tactical image management model that I use in many examples when I talk about DODAF and test requirement and test management. So you'll see here that in this model I've got a tremendous, or not a tremendous, but a large list of verification requirements here, and they have methods and the status. So what I want to do is I want to understand I want to first produce the verification cross-reference matrix, because that's what was asked for. So I'm going to go into Word here and go to my verification folder where I have my requirements that I'm looking at, my verification requirements. And I have a verification cross-reference table here defined. I want to load that, and you'll see here you're going to see the number, you're going to see the element, you're going to see the method, what it verifies, and what requirements are being verified in the table. Next. I actually ran this a few minutes ago. So now I have this verification cross-reference matrix table based on this folder in this project. Okay, the project name is Tim Model for the webinar. So here's my verification number, my verification name, the method, the requirement name, and the requirement number. That's the way we're doing it on this project. it could be the order of these things can be changed around as appropriate by just making the different changes on that table matrix. So I have this, but you know, as the chief engineer, I'm wondering, did we ever complete the planning for all these things? I should look at that. It just so happens that I also have a report that I ran a couple weeks ago that shows me the verification planning. So I'm going to load that table, and I'm going to get some different information here. I'm going to get the planning status of each one of these verification methods. You know what? My guys haven't completed the planning for some of these things yet, so that's another thing that's on their to-do list, but something I need to keep in mind and let the program manager know that I'm behind on those things. So just another little tool or report, if you will, that's in my system that I can pull out to see how far my team has gotten on some of these, on getting ready for testing this system, which isn't very far, so something we have to work on. So back to my PowerPoint presentation for just a moment. I think that the other thing I needed to do was do an SSDD. I'm really ahead of myself here. Here's the verification cross-reference matrix and how it gets done. And then system documentation, he wants the SDD done for delivery tomorrow morning. That's kind of a tall task, even if you're not in a model-based systems engineering environment. And these are the documents that I can produce out of core: the SDD, the IRS, Systems Requirement Spec, the SSDD, the SSS, and the TEP. Well, let me go back into my TIM model and show you just how easy it is for me to produce that SDD based upon all the work that I've done here in the last couple of days on this system. So here we go. Let's run an SDD. I'm going to run it with the primary component, which is the systems level. I'll include all these elements. And I'm going to include these 3 diagrams in my report. And I'll put it back into my model here. And now I get the SDD. It's in an RTF format, so the only thing I need to do is select all, F9. Now I have a table of contents generated and a list of figures, and you can see that I have all the information taken out of my model and in the SDD so that the chief engineer, my customer, the customer's engineer can look at my design and how far I've gotten in my design on this system, which is the tactical image management model. Save that again because that has all the table of contents and everything in it. So just because time is short here, I'll save any questions you might have on that just to go through my last few slides here. So here in a quick hour, it really took me about 2.5 hours this morning to go through and generate answers to these questions. But what would normally seem like an almost insurmountable task for me as the chief systems engineer over a week, much less a day, I can get all these things done in relatively short time with a model-based systems engineering tool. And these are the types of questions I think you get asked more often than not when you're sitting there day to day at your desk as the chief systems engineer. So Warren talked about SysML, and those diagrams are over there on the left-hand side of this slide. User and system specs, the behavior modeling, the architecture. I added a couple of diagrams at the bottom of these lists that are not necessarily SysML in nature, but are very helpful in showing that information in another fashion. And through the questions and the work I did in the model, I think I probably showed you how to do most of these things, these other SE support areas that you get asked to do as a systems engineering, as the lead systems engineer of the systems engineering practice. So my point behind this whole presentation today is that SysML is part of systems engineering, but you also got to do a whole heck of a lot of systems management. The systems engineer has to support the complete design and the complete project lifecycle. So he has to do things above and beyond what SysML is doing in the day-to-day operation of the project, and the model-based systems engineering tool set can support doing all of that much easier and much simpler for you as the chief systems engineer. So it's SysML and systems management, and that's what you want in a model-based systems engineering tool set. So with that, I'm kind of at the end of an hour here, and I didn't want to run too much longer, but I'm open for any other questions people may have, Eva.
All right. Thank you, Ron. We've got some great questions from everyone today, and I just want to say, those of you who haven't already, I encourage you to join our discussion using the chat feature in your webinar control panel. So let's see. Let's take a question from Rosemary. She asks, can someone load predefined library of SysML models to core?
A predefined library of SysML models. I think what you're trying to say is, can you load the views that you have from another project? And you really can't do that. If your project is based on a database, then I can take out from that database and a CSV export from that database, and I know what those definitions and what those views, what those elements and relationships are, then I can import a CSV into core and populate the elements. But you can't really bring the view in to core. Core is fundamentally based on a systems definition language that requires you to populate the element or the entity, which is all of these things, right? Requirements or components or functions, and then the relationships and the attributes associated with those. So for the functions, we have a description, and we have relationships as to how that function relates to the rest of the model.
Okay, thank you. Our next question is from Elizabeth. She wants to know if there are any types of reports that she might need to provide to a customer regarding verification planning.
So if you have your verification here, I showed you, let me switch to the other model here. We talked about the verification requirement. We talked about the planning of it. There's also, when we do in core, we do verification requirements, and those verification requirements are supported by verification activities. Let me close the systems engineering facilities here and go to the verification management facility, and you'll see the verification requirements, same requirements we had before, and we have these test activities. And I have a number of test activities. These test activities are the actual execution of these verification requirements, and they are related to test configurations and test items and test procedures. And it is a webinar we're going to do in the future on test and verification planning, but I'll just expose you to one other report here that I like to use, and that is the tracing the verification requirements to the test activity that's going to be used to do it. So I have a verification requirement to verification activity trace report that I like to run, and this will show me the verification requirements and the verification activity and the activity name that I'm going to use in my test planning to actually complete that verification requirement. And I could go on with this if we wanted to put in the description of the test activity or other things. I can add that to this table easily enough by just expanding the definition I already have.
Okay, thank you. Our next question is from John. He asks, is it better to start with high-level functions, capabilities, behavior, use cases, ConOps, etc., and concurrently define requirements based on them, and then concurrently define elements as we go down the hierarchy?
Well, I would say, John, that the way that we don't try to go down the hierarchy. The method we teach in our class called Strata is to work across any level of the system. So we want to work across the system level and look at the systems requirements that we have, look at the system functionality at a very high level, and look at how the combination of requirements and system functionality defines the system level architecture. Once we have that completed, then we'll go down to the next level and look at what requirement allocation or refinement we need to do, and what the next level of behavior is, and what the next level of physical architecture is. We don't go down the requirements or down the functions or down the physical architecture. If you do it that way, and we like to do it that way as systems engineers because intuitively we understand what we want to design is the physical architecture, or someone has said you got to use this COTS element or that COTS element. If you go down before you go across, you end up losing a lot of consistency and completeness of your architecture when you go down instead of across.
All right, I've got another one from John. He says, are all of the diagrams defined from a common database so that a change to a database item is automatically replicated in all the diagrams that use that item?
Yes, they are. I'll go back to the ventilator requirement. Oh, the other thing is, going back to your first question, John, we have several model assistants that run in core, and when I create a new component, it will automatically create a root level function for that component. We believe that a component doesn't exist in an architecture unless it performs some function, and likewise every function has to be assigned to some component. Otherwise your architecture is incomplete and inconsistent. But if I was to add, let me go to, I'm trying to think of an easy way to show this. So if we looked at this and we saw that we had this N2 diagram. And if we go back here to this hierarchy, I'm just going to change this hierarchy just to reduce this to just the level of the three systems that are in there, that are in our diagram. So we have this decomposition of the respiration, and we have the respiration unit, and we have these same three systems here in the N2 diagram. So if I was to go back to the hierarchy diagram and I wanted to add a new component, I'm just going to call it component 1. I'm going to say component 1 is built in this unit, and I go back to my, now I have this new component in here that I added. It also changes, it adds that new component in my N2 diagram. It's going to show it here as just a floating component here because I haven't connected it any place. It'll show it on my structured block diagram is sitting here too, but no definition to it. So a change to the database, fundamental change, adding a component to the database, making that relationship there, changes every view. It's changed once and shown many places. I think that's what you're asking, John.
Okay, Ron, I know we're running out of time, but I'm getting quite a bit of questions, so I'll take a couple more if that's okay with you.
That's fine.
Okay, I have one from Matt. He says, going back to the risk report, is there a way to view just the risk table rather than the entire report?
Sure. I have these three risks here. If I want to look at, I can look at my risk report. Let's look at just the risk output. If I want to look at just the table, I will remove these two things and run just the risk table. I'm just going to call this Rev A so it's different than the other one. And I'll open it with Word. You get this risk report, and it's just going to have the table. It won't have anything else in it. Alternatively, I could run a query to export a Word table, like the concerns table that I showed earlier. Another question, Eva?
I've got, let's do one more from John. Let's see, he says, is core a model-based systems engineering tool or a model-driven engineering tool?
I don't think it's model-driven. It's a model-based systems engineering tool. I don't know how to describe what a model-driven tool is. A model-driven tool would tell you you can only do things a certain way. You can do many things many different ways in core and show many different relationships. It's a model-based systems engineering tool. When we talk back about a model at one of our earlier slides, things come into and out of, I guess I would say, we provide a foundation, an underlying data repository that you populate and provide relationships in the manner that you see you need to have for your system. It doesn't, we don't require you to do certain things. I will suggest that you do certain elements and certain things certain ways, because from experience we know that that's the best way to do it, or the most efficient way to do it, but it's not the only way to do things. So it's not model driven. You're not driven, your design is not driven by the model. You have the flexibility within core to design as you need to design your system.
Okay, thank you very much, Ron. That wraps it up for today. I apologize if we didn't get to your question, and we will contact you directly to ensure that it's been answered. If you think of any other questions or comments, we invite you to post those on the forum of our community site at community.vitechcorp.com, and let me chat out that link to you now because it is quite a mouthful. There you go. And as I mentioned before, a recording of today's webinar will be posted in the resources section of our website within 24 hours. I'd like to thank you all for joining us, and I invite you to join us for our next webinar, which is also going to be presented by Ron Kratzky, and it's titled Exploring DODAF and Other Architecture Frameworks in Core. Let me chat that out to you as well. There it is in your chat window. So at the conclusion of this webinar, you will see a survey pop up on your screen. Please take a moment to give us feedback on today's presentation and also on what topics you'd like to see covered in the future. We've added some new questions to help us determine the best time to hold our live webinars, so please let us know what works best for you. So that is all for today. Once again, thanks so much for joining us and have a wonderful day.